Good afternoon, everybody. I'm Peter OHanlon. I'm an Intel software innovator, and I'm talking to you today about Intel RealSense devices. Over the course of this talk, I'm going to cover these topics here. I'm going to show you a brief overview of what RealSense devices are. We're going to do a bit of coding with them. You're going to see how you can interact with them. I'm also going to talk about what platforms are available on and talk about how you can get involved in RealSense right now. First of all, quick show of hands. Who's heard of RealSense? Oh, amazing. Did you all see, well, the ones who've seen it, did you see the GDC demos earlier on this year? Oh, you missed. Unfortunately, I'm not allowed to show them because it's copyright Intel. But go and search on them online on YouTube, and that's absolutely incredible. There's 4 guys standing on a stage playing drone pong. Seriously, they're standing in corners and they're just passing the drone backwards and forwards between each other using perceptual computing, just using gestures and making it move backwards and forwards. I've got no drone with me today, so we're going to have to do something else. I do have games you can try. I do have RealSense games. I was going to do a bit where I said, get somebody up and get them to try and that. But that's purely voluntary afterwards. If you want to have a go, please feel free. Okay. So, RealSense devices. RealSense devices are perceptual computing devices, basically. That's what Intel used to call RealSense. It used to be called perceptual computing. I first got involved with RealSense back in the perceptual computing day when we had perceptual computing cameras back in 2013. I was part of the group, the Intel Ultimate Coder Challenge, going perceptual. A group of people who got together to battle off and try this new technology that none of us had seen before, but which was a gesture camera. It was an astonishing device. It was really big, really clunky and really heavy. And if you had an Ultrabook like this, which is what it was available on at that time, you'd plug it in and it would pull your screen backwards. Which was great on a train, because you'd be sitting coding away and the person opposite you would realise all of a sudden that they were staring at themselves on a screen and every gesture they made was translating. That was my excuse to them. Okay, basically perceptual computing. The basics of it is it allows computers to perceive depth, that hence perceptual. It's not just depth that they're perceiving, it's voice, it's colour, it's trying to mimic the way we see things. So the techniques it use are analogous. Things like they've got an infrared camera and they use that to bounce beams and to capture depth data. Kinect users? Yeah. You're used to the idea from Kinect of that.
Yeah, playing with the SDK and built some basic interfaces. But
yeah. What I'm going to talk about as well is covering the perceptual computing. I'm going to talk about the differences between the different types of perceptual computing. So things like the Kinect, the Leap Motion, and the Intel offering. Right, this is your first bit of tactile. This is where I get up and say, right, this is a RealSense camera. That's it. That's a 2D and a 3D depth camera. But then again, so is that. This tablet you can buy, commercially available. On the back there's your standard camera, and here is a RealSense camera. So available now. Okay.
how much is one of these?
That is it's $99.
Okay.
Gets better.
It's a mini Kinect.
It's a mini Kinect, and it gets better in that actually you can buy Ultrabooks with them in now. Currently there are 15 Ultrabooks on the market worldwide that have RealSense cameras in. My personal favourite is the Republic of Gamers one. Oh, it's a beast. Trouble is, it's about 17 inches, but my God, it's amazing. Playing Elite on that with using gesture, it's fantastic.
Just got a new laptop last week.
Oh, sorry.
Can't ask work for another.
Yeah, it broke accidentally. Yeah, the RealSense cameras are now being built into devices. So what you see there, in terms of that camera, that you're actually getting inside hardware now, and it's ultrabook, so it's that thick. So it goes in the case. So where you would have the web camera before, now you've got one of those. That's Android, by the way. It's not just Windows. There's difference number one with the Kinect. But why? Sorry?
What is this Dell device?
That's an 87000. It's a Venue 87000. Yeah, it's about £300. Afterwards, please feel free to come up. I'll switch it on. You can have a play, try with the camera. Because of the camera on the back, you can do all sorts of fantastic things like refocusing. So you take an image, it will take all of you in depth, and then you can refocus. So you can pick, you're sitting at the front, and then you can do things like adjust the amount of blur, and you disappear at the back. You can do things like, okay, so right, I want to do colorization, and pick a person and say, right, okay, everything else is going to be black and white, but you're going to be colour. It gives some fantastic effects. Yeah, it's toys, and I love toys.
Can I take wireframe images? So you've got a 3D object in front of you, take a photo, and it builds a wireframe of the image in front of you.
You can actually do that with not with that device, not with the Android version at the moment. You can do it though with the one in the Ultrabook.
Right, yeah, so what I'm doing with Kinect, basically 3D scanning.
Yeah, 3D scanning is
Not
available. Yeah,
3D printing yet, but
yeah. Well, I say it's available. It's one of those things that Intel keep promising that the SDK will have, and they've just released a new version of the SDK. Because we're going to do a live coding session here. And because I had a demo already, I haven't downloaded the new version of the SDK. Because one thing they do like doing is breaking the old version. Going, oh, we found a newer, faster way of doing this, we'll deprecate that method and give you this method instead. Which is one of the reasons I'm writing a wrapper application for WPF developers to sit on top and abstract that away. Because we can take care of that underneath. So you develop against the API, and then let that take care of what goes on underneath. So there's some hideous code underneath going in there for things like, if the version of the SDK is 3.16, go down to this particular branch. If it's 4, go down here. But the reason for doing that is it means that you don't have to. And then you can roll out your code to different users using the same code base effectively without having to worry about what's going on underneath. And that's the thing, why perceptual computing? It allows us to interact with computers in a different way. So it's waving your hands around, it's gurning, it's pulling faces, it's emotion detection. It's an up-close device. That's what I say, it's inside the Android tablets, it's inside laptops, it's inside Ultrabooks, it's designed for being up close. It's not designed like the Kinect, for distance work. The Kinect is a great device, don't get me wrong, it is a fantastic device. If you want to play a game and you want jumping around in a room, the Kinect is fantastic. I love it. If you're wanting to interact with your computer and actually operate it, the RealSense is a better choice. And because it's available on other platforms, it spreads out, it becomes much more of a choice for other sort of usages. So you can see it coming up in things like hospitals, the big kiosks where you go and say, right, imagine going up to the kiosk and going, show me where the dentist is, and it traces a path through from you because it's recognised what you say. That's useful, being able to talk to it. Yeah, voice recognition isn't new, but it's now in the devices. And that's useful because you might be on crutches. So perceptual computing is about giving you the tools, all the tools you need for building compelling applications that can interact with they use it in completely different and radical ways. Now, the app we're going to build isn't a radical user application like that. We're not going to do a book, for instance. One of the great demos I've seen is father reading to his child, sitting there. It's your very happy families, and the dad sitting there reading the book, and oh yes, and the child sitting there, and they've done 3D segmentation, so they've extracted the background from the child and put the child in the book. So the child's actually interacting with pictures in there. That is a fantastic, fantastic thing. Most of what you'll see with RealSense at the moment are games, because the games companies have leapt on this rapidly. They're helping to push forward the innovation. There is one of the games I'll let you play afterwards is Lego. Oh yeah. Oh yeah. I was testing the camera this morning to make sure it still worked. In the hotel room, knock at the door, housekeeping, and she comes in, and I walked back into camera shot on the character, and it went, whoa! Because it picks you up, recognises you, and does it. It's got facial recognition built in. So it can sit and recognise you. So in the book case, it could recognise that you're up to page 30. You could give it to your sibling who's maybe at page 15, and it'll take them to the appropriate book, appropriate page. With emotion detection, it can say things like, you look sad. How about I make this a happy ending? Or if you're my daughter, who doesn't seem to like stories with happy endings, go, you're too upbeat. How about if the main character dies? Probably from some lingering disease. Oh. Okay, we're talking about natural user interfaces. Again, this is one of those strange terms that comes up. It's a very amorphous term. It means different things to different people. But basically, natural user interfaces are the next step. They're an evolution away from GUIs. They're a way of saying, actually, you're going to interact with the computer in other ways. It's not just going to be a button on the screen that you press. Microsoft took a big step towards that with the sometimes lambasted Metro interface. You know, when they went with Metro or New, or as it's now called, Windows interface. They made that step on because they realised that form factors are changing, usage scenarios are changing. So people don't want fiddly little tree views. They want big buttons and they want things outside across because they're using things with their thumbs. Well, we evolved this because now we're using things with our hands, we're swiping. By the way, that's a great thing to do on a train, control the computer with your hand recognition. Because I guarantee you can get a carriage to yourself if you're sitting there going. The thing I'm worrying about now is that camera's just caught me doing that, and that's for posterity. Has caught me looking like an idiot. And normally I save that for people I know. Okay, so the different types of cameras. What types of cameras do we have? Well, what we have here, that device there, the first one you saw, that's a front-facing camera. Now, that camera is called the R200. Sorry, the F200. The R200. I'll give you a clue. There's an Intel naming convention. If it says F, it's front-facing. The rear-facing is the R100. That's the one that was in the tablet you saw. So, the front-facing one, it captures your hands, your fingers, it's capturing your face movements. So it captures 78 points of your face. So you get a view around here. I'll actually show you what it captures because you can take a look at it in a web browser. Oh yeah, it runs in a web browser as well. So you can actually, if somebody's got a RealSense camera, you can run the app over the web. You can actually have it running to them. It's new forms of interaction. So again, we've got web browser, we've got Android support, we've got Windows support. Oh yeah, new version of the SDK is also running Windows Store. So you've got Windows Store support. Up to 3 weeks ago, I couldn't have told you that. But they've officially announced it, so I'm allowed to say now. We've got a rear-facing camera. One of the cool tricks you can do with that camera, with the tablet, is you can take it and you can measure things. So you can say, yeah, you can say, take a photo, and then when your wife says to you, that parking space is 6 inches, well, there you go. You're right. You're much better at estimation than I am. Obviously, I've talked about refocusing, so you can take the image, then you can do all sorts of things with it. You can do the focus blur, as I say. Please come to me at the end. I'm going to try and keep this below the 1.5 hours so you get the chance to do this, because this is cool, this is fun. Okay, so how does a computer see? That's an odd question. Yeah, because we talked about the fact that one of the things, it's trying to perceive the world in the way we are. Well, what it does is it assigns a hex color to everything. So basically, it's your standard, as you would recognize it, it goes and says everything has a hex value, and that's the color. Then what it does is it applies something called segmentation. Now, segmentation is this idea that it's looking to differentiate. So you've got your light greens, your dark greens. It's looking to try and get the depth in there. So it's using that IR camera to actually try and work out the depth of something. So you can say, right, okay, that value there is green, but that's 1 meter away. This value here is blue, and it's 0.5 meter away. Therefore, the two objects aren't together. What it then does is it's looking for corners. Have you ever? I mean, does everybody watch? Does anybody watch NCIS or CSI? And you know, when you get them and the face comes up and then it starts putting things, it puts points all over and goes, oh, that's not the way facial recognition works. Big surprise. It's what they actually do is they look for rectangles. So they break your face up into little rectangles, and then they can match those patterns based off that. This isn't a new technique. OpenCV has been doing this for years. In fact, a lot of what you'll hear in perceptual computing, people say, yeah, but you could do that before an OpenCV. You could. What's in here now is that evolution of an SDK and try and bring it all together. Once it's found those corners, then what it tries to do is look for textures. So it's looking to say, okay, we've got this sort of light greenish patch here, and we've got this blue patch there, and we've got a red patch here. And from that, then, and this is where I love programs like NCIS, where Abby's in a lab and she's going, hey, I got a match. Yeah, it makes an educated guess. That's the best it can do. It makes an educated guess. If you get two things with a roughly similar outline and roughly similar colours, it's not going to be able to tell one from another. By the way, that's how our brains work. But our brains are so fast and so powerful that we can make these calculations in real time, unless you're me and my age, where I look and I think, I met you, who are 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 you? Oh yes, you're my wife. The brain is phenomenally good at this. Computers are getting that way. There are certain hardware demands, which is why these devices are only now coming into fruition, because only now is computation power getting fast enough, is battery capability getting good enough to cope with this, because as you can imagine, that going on all the time could be a tremendous drain on your device. And the idea is, if you're running the device, you don't want to be going, yeah, hey, I'm doing facial recognition, oh, I've run out of juice. Well, power up, take the next one from the charger, oh, I've run out of juice on that one. The idea is that these devices, low power consumption, and they can use tricks and techniques to behave the way we do. My favourite slide. Yes, it is that simple. That is me, by the way. Okay, so what features do we have? Well, as I've said, we have motion detection. Well, tell you what, you can read them. I mean, there's nothing worse than somebody sitting here and reading them all out to you. You know, we've got this and we've got that. I'll just take a sample of those. You're actually asking about object tracking. You're asking about being able to scan. That's what's in there. When you're object tracking, you can then take it, rotate it, scan it, printed out on a 3D printer.
That's built into the framework now, is it?
Yeah.
So it's been quite nice.
Yeah, no, it's built in. Remember?
Not the connected, is it?
No, I know. Yeah, it's... the thing is, I mean, again, right, okay, next issue, difference between the Kinect and the RealSense camera, and the Leap Motion. Okay. Well familiar with the Leap Motion? Yeah, it was the one that came out with that little rectangle that sat on there, and you put your hand over, and that was really cool, and that was my first exposure to anything that was perceptual. And I got it, and it was great, you're doing that, and thinking, oh, look at that, that's fantastic. Tap. Oh, where's my hand gone? Okay, move it back in. Oh, where's my hand gone? Move it back in. Oh, it's too high. So you have that very limited range that you're working with. Now, what you get out of the RealSense camera is this frustum. So this shape coming out like this that you sit into, and so it's about 1.2 meters in depth. So when you're working with it, it's designed for being up close. As I say, the Kinect is great for that distance. So you've got the Leap Motion, which is working on point data. So it's actually pulling up points of your hand. So it creates effectively like a cloud that represents your hand. That's cool to see when you render it out and you see all the dots and that. But again, it's limited to that. Now, the Kinect is designed for big gestures in a big space. So you have a minimum distance that you have to be before it starts recognizing, and that's quite a minimum distance. Now, I've done a lot. I've done an awful lot with RealSense devices. I spend a lot of time working with these. I'm on monthly calls with Intel. We do a catch-up every month to talk about what's coming, what direction should be taken, and things like that. And I'm lucky to be involved with them in this respect. And I'm really lucky because one of the things that it is when you do use these for any length of time, if you're using a Kinect, it's bloody tiring. It's those big motions you're making. We've seen the Avengers, we've seen Iron Man, we've seen all these films where they have these big interfaces on the screen. They go like touch and pull and drag and that, and they look great. They look amazing until you try doing that in real life. I mean, I'm no Arnold Schwarzenegger. You know, I'm not a big, strong guy, and if I'm doing that, after about 5 minutes, your shoulders are hurting, your arms tired. With this, I just put it down. I'm not making big gestures, it's designed to work. Close, so I'm going to put that there and go, yeah. I can angle it back, you know, I can angle the lid backwards and forwards on the Ultrabook. I can angle the camera backwards and forwards so I can change the angle. So I can make it work for me. But as I say, it's not designed for you standing in a lounge playing a big game. You know, if you're wanting to play Assassin's Creed or something where you're leaping about the room and dispatching enemies, this isn't the device. If, however, you're doing, I don't know, you're working on a spreadsheet where you just want to scroll down or up, this is the device. You can do that with these. You can actually control windows with touchless controller integration. So it can take you, cut you out of an image, get rid of the background. It's called segmentation. And then video conferences become really interesting because you can put yourself anywhere. Bali. There's one lad who's involved, Lee Bamber. His demo of what he was doing with RealSense was absolutely incredible. Because he did that. He did a video conferencing where he could put himself into all sorts of backgrounds. So 1 minute he was sitting in a medieval castle, sitting at a table, and next he's in this futuristic room. And to add fun, he then started sending fire out from his fingers, which makes video conferences amazing. Skype would be incredible. Actually, it will be, because Intel and Microsoft are working together to integrate into Skype. By the way, this isn't all it can do. That's the version of 3.16, the new version that's just come out. It also gives you things like pulse detection. Oh yeah, It tracks the colour of your skin as it changes. So minute little changes, and it uses that to estimate your pulse. In my case, I think it said, Pete, you're almost dead. Okay, so you get the SDK. Right, what is in the SDK? Well, runs on Windows 8.1, runs in a browser, as I've already mentioned, runs on Android, as we've seen there. It's not going to limit you to what language you use, though. It uses a few. So you've got C++, C#, Java. Yeah, for Android you can do Java, you can do JavaScript, you can do processing. I'm in the process right now of working out how I can integrate RealSense with Xamarin Forms so you can create your Android app in C# and roll it out. So I was having an interesting chat last night with a couple of the Xamarin guys. So this is, again, this is all the sort of ways you can take this. Let's say it runs on popular game engines. Big one, obviously, Unity. Unity had support for this for quite a while. Every iteration of the SDK, the Unity support gets better, and there's a lot more that you can do with it. So you see, check out some of the demos. They're all written in Unity, all the games. It just shows how powerful it is. Earlier versions of the SDK, we had to rely on our own algorithms to do things. The SDK has evolved and it puts all sorts of algorithms available. So I used to have to write my own smoothing algorithms, so basically wrote a Kalman filter so I could do hand smoothing and face smoothing. You'll see the effect of that in a little while, what effect the smoothing has. But now that's built in, which is really important for games, because you're trying to control something like that. As I say, I mean, you think your hand's still, but the computer's detecting tiniest little movements. So with the smoothing filters, it applies that. Okay, so what do you need? Well, I want you to dwell on this one because I'll be putting the slides up. So if you want to know what you need, just grab a copy of the slides. Okay, so what is it made up of? What actually is the camera? Right, well, you've got the infrared camera, you've got the laser projector, and then you've got this 1080p image sensor in the middle. That's just a polite way of saying that bit's the web camera. So, as you can imagine, the two bits on either side, that's the thing that's responsible for the depth perception. That's the bit that's responsible for actually getting the image data. But when you integrate it with that bit in the middle, you get some fantastic results. Currently, if memory serves me, the actual camera, the IR camera resolution, rather than the 1080p, is 640 by 480. So it is different. You will get different results out of that. And you can see that effect when you try some of the SDK samples, when you cut things out. But that's where the actual SDK steps in to take away some of those differentiations. Okay, so you write an SDK-based application. So we're sitting there, we're writing the next great game. That then may sit on some language-specific interfaces. Those interfaces might be the Java interface, there might be the C# interface, there might be JavaScript. In the case of C++, it doesn't go through those language-specific interfaces, it talks directly to the API. So that's why that green arrow is pointing down to the SDK interfaces. The SDK interfaces effectively is the abstraction we talk to that sits on top of the core of the SDK, so all the sort of the heart of it, which is things like session management, things like that. Then on that we then have the ability to do the input-output modules. The input-output modules are actually the bits you'll interact with to get that image data backwards and forwards. You find you'll typically be running around about somewhere between 50 and 60 frames per second in your application if you write it efficiently. So you'll keep hitting those regularly. Then the algorithms that I mentioned, things like the smoothing algorithms and that, they're all built into the SDK. And every time a new release comes out, as I say, they add new algorithms that deprecate some because they've found a faster, more efficient way. They have teams of incredibly smart people working on this. Now, One of the things about developing applications, and natural user interface applications, is that you have to be aware of internationalization. Yeah, I know. Internationalization is boring until it's not. This is internationalization like you have never seen it before, because you're doing gesture recognition. Gestures that we find perfectly acceptable over here, in some parts of the world are less so. Now, because we're being recorded, I'm not going to show you one. Because if this goes to Brazil, it would rouse him. I'd be the Jeremy Clarkson. And that's what they'd look like. Yeah, you have to be aware when you're writing these natural user interface applications that some of the gestures you use that are acceptable in one country aren't going to be acceptable in another. This is an emerging field. What are standard gestures? What do we have for standards? Because everybody knows about mouse clicks and swipes and that on the screen, but gestures in 3D space are, this is new ground. Some things are starting to come to the fore. Things like if I want to press a button on a screen, well, first of all, you make the button really big. The second is it's a tap gesture. Swipe and swipe, fairly standard. You can do swiping around, swipe up and down. Actually, swipe up and down is a lot harder than swipe left to right. So that's not natural gesture. You may be tempted to use thumbs up for OK. But then you say, well, what is cancel? Your temptation, these are standard gestures. Your temptation may be to do thumbs down. But again, that's a more complicated, it's a more physically demanding gesture. If you don't believe me, in the privacy of your own houses tonight, try them. I'm not going to make you do them here. So what is the potential of this SDK? Well, we can give touch-free kiosk. I've already mentioned this. Working in a hospital, you've got the ability to have people working, not touching keyboards, not touching screens, not touching. It's because they're clean environments. You may have them in kitchens because you want a more ruggedized environment. You want something where you're cooking, you don't want to be smearing the screen. Games, yeah, it's the obvious one. Games are really pushing this forward, as I said. Then interactive books. This to me was actually this was the technology about this that excited me the most. Because when I saw this, I thought, if only I could write books. If I had the talent to write a book and then to draw it, I could do this side. Because that is going to be a big area. Kids loved the technology. I have 2 children. They love playing with this. They love interactive. Keyboards are boring unless you play Minecraft for some reason. But then Minecraft becomes more interesting when you can use your hand to fly, when you can control where you go by moving your body and doing that. Subway Surfer, you're doing that. I'm looking at blank faces. I thought everybody knew Subway Surfer. It's, the Lego game is like that. As I say, you can have a go of it. Brilliant. I also have a Madagascar game for you to try. It's Dancing with King Julian. Collaboration. That's putting yourself in. So the segmentation I was talking about, it's putting yourself in the app. So things like doing an architectural overview, actually seeing yourself in there. Take a segmentation of you and put yourself in. This is going to revolutionize things like those home makeover shows. What does this person look like? Well, there you go. I've done that. Why do I need some overpaid idiot on TV to tell me when I can actually go in and just redecorate my room? Enhanced tutoring. Now, the example I give of this was slightly overtaken a couple of months ago when HoloLens was announced. But it still applies. Just HoloLens. Yeah. Basically, enhanced tutoring is the ability to do things like because you can do segmentation and you can have all this. Imagine a doctor practicing an operation, because this is capturing very fine movements. When this captures down to it's a micromillimeter level, not just. Imagine a doctor practicing. I mean, this would make the operation game absolutely incredible. So they're working on effectively a virtual person, and they can see the effect on the screen because you can superimpose the reality on there. That's incredible. And then you can have somebody watching, correcting. So the tutoring there is fantastic. Or you may have somebody who wants to practice learning to drive, and you're terrified of letting them out in your car until they know how to steer. All of this is possible. Okay, they may feel like a bit of an idiot sitting there doing that, but you can always give them one of those little Tommy steering wheels. There's many more usages. Okay, I've waffled enough. It's time to do some coding. That is, after all, why we're here. Okay. That hasn't swapped over. Darn it. Just give me 1 second. That should have swapped over to Visual Studio. And it hasn't. Just 1 second. That's why, for some reason. No, I did not. Right, sorry about that. Just wait for that to come. Yeah. Okay. So we're going to build ourselves a little bit of an application. One part of this you're going to be able to run on a device that doesn't have a RealSense camera. So you're going to be able to at least try the sample out until you get your ultrabooks with RealSense. The other part will rely on the RealSense camera. Basically what we're going to build is an application. It's going to have a bit of speech synthesis in, so it's going to talk to us. And as you can see there, it's also got hand management. So we'll see how the code works, how we build it up. We'll talk about some of the pitfalls in there and some of the little gotchas to be aware of. Okay, so first of all, I've written this application as a WPF app. I had thought about just doing it as a console application. It doesn't really matter what you have at the back end. But the idea is from this, you can see how you can isolate the application from the underlying perceptual computing. It's a good thing to put in place because the first gotcha is this is released as a 32-bit and a 64-bit version. So you get 32-bit DLLs and you get 64-bit DLLs. So there's a little trick I'm going to show you here which you can do in Visual Studio that will allow you to target the two environments and get them to build appropriately. So, first thing is to actually, if I just unload this, unload the project. This small screen I'm seeing here is really confusing me. Right, so if I edit it, okay. What I do when I create an application with RealSense is I have a common directory that I put the libs that I need. So I have an x64 and an x86, an x32 directory. And from those, I'm going to pick up the relevant DLL that I need for the version I'm building. Because when you see the references, if you're in a 32-bit mode and you wanted to see it and then you swap over to 64-bit, if you don't do this trick, it'll look as though your underlying references disappeared. So what you do is you can create this section here. Basically in Visual Studio you can extend it by creating your own item groups. What we're doing here is we are bringing in the perceptual computing CLR CS DLL. So there's my naming convention. I have a common directory, as I say, it's just a libs folder, and I drop the ones in I need, the x86 and the x64. Right, so from that, then all you do is, that gives you the managed code reference. There's an unmanaged DLL that you need to add in. And what I do then is, I output to a common directory, so either a 64-bit or a 32-bit directory. And I have, if I reload this, I will be making the code available, by the way, so you'll be able to download and play with it. So all I do is I just, in the relevant configuration, so the x86, the debug in the release, I just match to the same output paths. So when it builds and releases out, there's a build event that runs at the end, and what that does is it copies this other DLL. That's the unmanaged code. So you've got the managed code interface that talks to that. So you need that reference. So this trick, it just copies it in for you. You can put these wherever you like. This is just the way I find easiest to work with it. Okay. So what we're going to do, first of all, is I've created a basic architecture here with some various bits and pieces. So we've got a couple of structures there to represent a point in 2D space and then a point in 3D space, because when you get data back, you get it in image coordinates, so it's your x and y. You also get back in world coordinates, so you get the z coordinate as well. So it's useful to be able to see that information. So these two structures here, the point 2D and the point 3D, give you that as effectively, I'm giving you it as a translated version. Okay. This exposed modules, I've just done it to add in to say, it's a little convenience method of enumeration in here, because I'm adding the implementations of things into a dictionary that I just call, and then I just go, right, it takes care of calling out the appropriate one by using that. Right, what we're going to do is this RealSense tracking. This is the heart of where all the processing goes. This is the thing that our WPF application is going to see. It sees this, everything else it's not going to be able to interact with. So one of the things you're going to see is internally, one of the things I do is I render all the other instances that are in there, render them internal, so that they can't be created, so they're not going to be created from outside. The reason I'm doing that is because I'm actually passing RealSense information around inside, and I'm trying to hide that from the external consumers. So what we're going to do here is, the first thing we are going to do is initialize the session. So as you can see here, I have this PXCM session and PXCM Sense Manager. The session effectively is going to be the instance that I'm running against. So it's just a standard session. The naming convention, I agree, is a bit hinky. PXCM. This is one of the biggest complaints I've heard from people, is they don't like the naming convention. Part of it is because Intel have put these classes in the global namespace. So that's why you're not seeing any usings, using Intel.RealSense or anything. They're in the global namespace. So they're using this PXCM as a way to uniquely identify, so you're not getting a clash with another session. What that actually stands for is, the PXC is perceptual computing. The M, I have heard various explanations why it's in there, and I'm going to put it to rest now. In the managed world, the RealSense is threaded by default. So it's thread aware, so you can run it across multiple threads. The C++, the raw version, you have to specifically say, I'm targeting the threaded version or the unthreaded version of the underlying library. And basically, once you're down that route, you're down that route. So you have to make the decision right up front. So I've heard people say that the M means it's multi-threaded. It's not. What the PXCM stands for is Perceptual Computing Managed. That's why the M's in there, just means it's managed code. You'll see the same interface names and that appearing in the Java version. You'll see them appearing in the JavaScript. You'll see them appearing all over the place. It's the same naming convention. Okay, so what I'm going to do, as I say, is actually I'm just going to create myself an instance of the session. There we go, I've got a session. So if I run the application, I'm going to be able to get that session and I'm going to be able to interact with it. So what I'm going to do now is I'm actually going to initialize this Sense Manager. The Sense Manager is the heart of communicating with things like some of the input-output devices. You'll find it's used all over the place. It's your route between the algorithms and that. So all we do is, off the session, I'm just going to get myself an instance of the Sense Manager. There. Now, to show this in operation, first thing I want to do is I am going to show this. I'm going to go and grab some information out of the SDK. So what I'm going to do is get myself some version details. So what we've done there, from this I've said I want to get the version information. I was talking before about this is actually really useful information if you're having to support multiple versions which deprecate and that. And if you look at the documentation, at least up until the last release of the SDK, the documentation was wrong on how you got the version. That's why I'm showing it here. So if you go and look in the Intel docs, it'll tell you one way, and it's not right. This is the way you get the version. It's a lot simpler than the way they talk about it. Right, and what I've done is I have exposed a property. And what I'm going to do is I'm just going to I'm just going to actually write the version out. So from that, I've got a major and a minor component. So as you can see, they don't do sort of sub-release versions. It's always just major and minor. So if I run this up now, praying that the God of Demos hasn't been watching me. Yay, there we go. There's the SDK version written up at the top. We have just added that. That's what we're doing there. So, by the way, this is the interface that we're building. Cute, isn't it? Okay. Thank you. Thank you for coming. Right. Now, that's not a lot of, that's useful information, but it doesn't actually do a lot. So we're now going to start to interact with the camera. Because this is, after all, what you want to be doing with it. So, now, the underlying SDK gives you two versions of the way you can interact. It has the easy managed version, and the easy managed version is, it basically gives you a processing loop. It does everything for you, and you just hook in and say, okay, I want to hook into this event and do this, and I want to hook into that and do that. I'll put a handler here. It's good, but the problem is it doesn't give you overall control. So they also give you a version that gives you that fine-grained control, and that's what we're looking at right now. So what I'm going to do is, I've got this loop here. This is it's like a game loop effectively. So what we need to do in here is, first of all, is oh, sorry, I apologize. Yeah, I put that in the right place. Yeah, putting that in the wrong place there. Yeah. So we actually, helps if I read the screen. What we're doing here is we initialize the sense manager. I could have done this anyway, anywhere I wanted before I called this. And then what I'm going to do is actually acquire a frame from the camera. So when it's running, I need to get each frame as it goes through. To do that, this is what I was saying about you interact with the device through the sense manager. So I'm going to acquire a frame. I'm passing this parameter false to it because I don't want to wait for it to have a frame to give me. I actually want to all the time get it. Because sometimes if you set up things like hand tracking, for instance, it's going to wait until it sees a hand before it processes. So by doing this, I'm saying I want to do this every time. I want to take control. Okay, so I've got this method here called process, and all process is going to do is go off and call my other modules, which we'll be building up very shortly. And then finally, what I want to do is I want to release the frame. This is very important. You've grabbed the frame, you have to release it. Good programming practice. I really should have put that in a try finally. So I apologise. So now if we run this, you won't actually see a lot, but it will run. The camera will be initialized. It will do something. So if I run it up again, the sense manager is interacting. It's now acquiring frames. It's doing what it needs to do. The only thing is I haven't actually told it what I wanted to acquire. You know, I haven't actually given it any underlying details of what modules I wanted to work with. It's one of the things I said earlier, is in order to keep it low power, you actually enable to say, okay, I wanted to use this modality, I wanted to use hand recognition, I wanted to have touchless control, I wanted to use things like I wanted to use the segmentation. So you actually enable things, so it's an opt-in method. So what I'm going to do, first thing we're going to do is we're actually going to add hand tracking. Right. I've created again a basic structure here. You've got a hand. There's 22 points that it recognises on your hand. I've chosen just to represent the tips of the fingers and the midpoint. But you can track all of those points individually. Each of these items, so if I go and show you a hand, that hand there, it represents a tracked object, and all that tracked object is doing is actually capturing the position. Basically, I expose the position out of that you're going to be tracking. Okay, so in the hand management, first thing I want to do is set up the hand module. So what I'm going to do is, I do apologise. These gives you a good idea of everything that you can track individually. So in the new version, enable pulse as well. So as you can see there, it does make it easy for doing that opt-in. The streams methods are for capturing colour streams. It's for capturing stream data as it comes through. But most of the times you're going to be coming in. The one you're interested in is enable 3D scan. It's that one at the top. So I'm just going to enable the hand tracking. And what I'm going to do is actually set up a hand module. Now, just because I've actually said I'm going to track the hand, doesn't I actually now need to hook this to the hand module. I actually need to hook it into what's going in internally. So what I do here is when I get, I'm actually going to tell it that I want to query hand data. So again, as we see, everything is off the sense manager. Now, it's one of these, you may notice that I've created these references outside of the actual constructor and that they're at their instance level. The reason they're instance level is because we want to be able to dispose them. Everything we've got here, because it's an unmanaged resource, you need to be disposing them at some point. So that's what we're doing there. So we make sure we've got that set up, and then it's disposable. So I'm going to get some hand data now. And what I want to do is, actually, the hand data comes out of the hand module, and I'm going to create the output from that. Okay, so I've got the hand hooked up. Now let's configure it. So what I'm going to do now is I'm going to create an active hand configuration. This effectively tells us, right, I'm setting this up now that I can actually do live tracking with it. So, because you can work with, we're configuring it for different things. The reason we're doing this is we can actually work with left hand, right hand. So you can configure, so when you set up the configuration, we can say off this, I want to do things like, off this configuration, I want to enable alerts. The alerts are things like if you're going out of bounds, if you're moving in too close, if tracking has been lost. I also want to enable gestures. You can pick which gestures you want to work with, or you can actually pick all of them. So to do that, all we do in the hand configuration, all that configuration, as you can see, all the enables are things that we want to drag out of that. So what I'm going to do is enable all alerts. And then enable all gestures. Okay, now I'm leaving that section there to do enable smoothing, because I want to actually show what effect the smoothing has when we're working with it. Okay. Right. Now, this again, one of the things you have to remember is when you've actually set it up, you have to save your configuration. So to apply it, all we do, every time you make the changes, you can make as many changes as you like, you can batch them up, but you need to apply them. So you'll apply all gestures, you'll apply the changes. Okay, right, where am I up to? So, what I'm going to do now is actually update the hand data. I have a slide, you'll see the slide in the pack, that often I forget to do this. And I have a slide of Jean-Luc Picard berating me for doing that. It's my way of reminding myself. Because if you don't update the hand information in the tracking, then no matter what you do, you'll get nothing back. So every frame, you need to update it. So the process that I talked about before, that was coming from that RealSense tracking, it's just looping through, calling these modules every time. The process you can see here, this method, all it's doing is telling it's going to track two hands. It's tracking the right hand and it's tracking the left hand. So in here, I'm updating the information that I need, and then what I'm going to do is I'm just going to create myself an interface to a hand, and right now this is one of those points that is really important to be aware of, and one of the things you need to do a lot of the time is when you issue a statement, you need to check the return status. Most of the statuses, most of the calls you'll make, they'll give you a return status. It's a PXCM status. Yeah, I've just aliased it with a success flag. The reason I'm doing it here, I'm going to talk about it here, is the processing that happens immediately after this. Because I'm tracking two hands, if I didn't have both hands in view and they were being tracked, the code will fall over. The application would fall over because I'm not checking the status, and I'm going to get something back that says got no data. So check the status. So all I'm going to do here is I'm going to query the hand data, and the access order is this access order right hands and access order left hands, so tell them which one it's looking at. Then I'm actually saying that of the access order, I wanted to output this hand information. So if it's not successful, I'm just going to return out at this point. Okay. And resharp is telling me that that's redundant because I've not added any other code. Right, now what I'm going to do is actually track the position of the hand. And getting the information. And then what I want to do at this point is I want to update with the hand position. There you go. Oh. As ReSharp have been a bit aggressive with its brackets for me. So what I've done there is I've tracked the position and then I'm assigning it to my hand position. The hand position is this, it's in this tracked object. It's just a wrapper around the 2D and the 3D structure. Please download the code and have a play around, have a look at it, and you know, I'll, if you need to get in touch with me online, I'll answer any questions that you have. This is just fairly, once you look at the code, you'll see it's fairly logically structured. There's just lots of little modules here. So now if I run this up, okay, wow. Right, the SDK privacy notification tells me now that it is actually recognizing. There's a little green light here. Oh, by the way, that's my hand moving the cursor. And as the cursor goes over the buttons, it gets that little bit of a thing. So the shadow goes in, the button appears to move. It's actually a rectangle. So you get all that movement. There's just moving back and forth. We now have hand recognition. I'm querying the right hand, and I'm transforming the image coordinates into a screen coordinate.
What point of the hand does it track off? Does it take from the centre of the object?
It depends. You choose what you wanted to track. I chose the centre of the mass. The centre of the mass is that. I'll actually show you where you set that up. Oh. There it is. Right. When hand management. Yeah. So as I'm going through off the hand, and where did I set it up? This is where, because I've just done this, everything seems to, that's why. Right. Yeah. So that track position method that you saw there is just an extension I put in that I wanted to take the center of the images, the mass point there. That's basically, it's that point there. Let's say you're tracking 22 points on the hand. I chose to just track that. Sorry?
Can we move just with the finger?
Yes, I could have changed that to any point that I wanted. So you can actually. I'm not tracking the fingers just yet, so you wouldn't see that.
Okay.
But you can track from the fingers. You can track from things. You can actually track each node. So basically, you got that. They're all nodes, same as that, and that, and so on over all the fingers. So you can track all of those individually.
So the hand, is it looking for an open hand? Is that kind of what it is?
There is an openness about it, but it's not looking for an open hand. It's looking for the nodes.
Yeah.
It actually recognizes the nodes in 3D space. You can get some very weird positives if you move your hands in very fine and start to do things like that and move your hand around like that. It can lose the tracking a bit, but they keep improving the algorithms underneath that that are doing all of this.
So that's it, is if you used a ball on a stick, it wouldn't recognise it. If you put your hand there, it'll recognise it as a hand and then it will respond to it.
Yeah. Yeah, it's looking for those.
It's not just looking for an object within a certain range.
No.
Okay.
Yeah, it's one of the really cool things. That's why it's they talk about adding new bits in, so as you look to extend to track, who knows, they may go up to like the elbow, so they have to actually be able to recognise that these are discrete units.
Right.
So yeah, it is pretty cool what they can do with that. But yeah, you can track off any point. And the only reason I chose to do this is because I just wanted to demonstrate the cursor moving around the screen, and I'm controlling it by the hand. And I'm aware that time's pressing, and I really want you to be able to have a play. So it's not to have a play, a serious trial of the applications. Okay, so that was sort of hand tracking. Now I did say that one of the things I wanted to talk about was as you saw when I was moving around, it was pretty jerky. So there is the ability to smooth, hence this thing in here, which. So all I'm going to do is I am going to, off the Sense Manager, I'm going to get off the session, and I am going to create an implementation of the data smoothing algorithms. What did I call it? Data smoothing. Funny. Now there's different smoothing techniques. They've got 1D, 2D and 3D smoothing algorithms. So it's 1 point, 2 points and 3 points basically. And what I want to do is I am going to actually create a quadratic smoothing algorithm here. So if I go to smooth the 2D, yeah, that's it. And off my data smoothing, I'm going to create a 2D quadratic. So again, you can see there's a spring or stabilizer or a weighted. You can see the different forms of smoothing algorithms. It's worth experimenting because each application can differ. Because I've got a very big surface area, I'm fine with the quadratic smoothing. To be honest, their implementations were a lot better than the Kalman filter I used to apply, because I used to do weighted averaging as it went over a period of time, and then I need to knock out those points, and you got a bit of a lag. These algorithms are much better because they're much more adaptive. The new SDK, we got rid of the this module to introduce an even simpler and faster module. Yeah. So all I'm going to do is, which one did I say I was going to create? The quadratic. Yeah. And right from that, right. Okay. Now then, what I'm going to do is I'm going to add a sample. So again, all it does is you add data and it adds a sample, so it's learning over a period of time. And to the sample, what I'm going to do is, I'm just checking I'm in the right thing. That's me, sorry, I apologise. Actually need to add it down here. So that was setting it up in the constructor. Here's where we actually need to use it. So, and what I'm going to do is add the and I've created an extension method which is to a smoothing point, because internally these all have different representations, PXCF, float 32, PXCF, float, and so on and so on. So here we're passing in the, we're taking this 2D version that we've already got out of the point 2D, and I'm just smoothing it, giving it something back that the smoother can use. Right, from that, what I want to do is get the So I'm going to get rid of the position that's already there, and what I'm going to do, new track position, and oh, I have to remember that ReSharper does that. So again, I've just I'm creating the 2D point, and because I'm doing this track position is my own internal struct, I need to make sure it passes in the world position as well, because if I don't do that, then it's going to complain because it doesn't like you to update structures without passing in the full information. So there we go. Now if I run this, and if I've done my job properly, and it's a more stable image. There is some movement there, but it's a much more stable, as you can see. So sometimes you also get false positives on which hand it recognises. Sometimes it swaps them about, thinks your left hand, your right hand, which can be a bit confusing. So there. Yeah, it's, as you can see, it's a much smoother image movement. What will I do that? It'll bring me. The reason that was jerking was because the centre mass started to become occluded. It starts to get a bit off. But yeah, to get back to the question about is it looking for openness, there is an openness factor, so you can work out how closed your hand is. You can track visibility based off that openness.
Will it recognise the fist?
Yes. Yeah, it certainly does. Actually, it's a gesture. That's one of the gestures that will come up and tell you that it's clenched hand.
What's the minimum range on that one?
The minimum range is about that far.
Okay.
Yeah. It's designed for, as I say, for you to be able to be up close, and then it's back to about 1.2 meters.
I say with the connect together within a metre and sending out 2 hands.
Yeah. No. The dog walks past and it complains about having recognised player 3. Now, I'm aware of time. I'm aware of time's running on. I was going to add speech synthesis, but what I will do is I'll post the code online. I'll put an explanation of how the speech synthesis works. You're more than welcome to download it, have a play with it, because you can use the speech synthesis you can use without the camera. You just need the SD key, you don't need the camera for that. Similarly with voice synthesis. I'll have a link out to, I'll also put a link together for areas of interest that you might, other demos that you might want to look at, things that people are writing about. I am going to blow my own trumpet a bit. I'll also link back to my open source RealSense project. If you want to connect with me on Facebook as well. I run the RealSense experts group on there, which is basically it's the people from Intel, and it's the people who've been moving and shaking so far. So if you want to get in touch, please feel free, and can get you added in, and you can actually interact directly with the same people that I talk to. The good people, they're really, really welcome feedback. What they're after is the more people who use it, the more people who try these devices, the more people who work with it, the greater the things. That's very bizarre doing that, watching your hand moving around. Yeah, the more feedback they get, the better it is for them, because it makes the product stronger, and they want people writing for it. So I'm sorry. The question I should have asked at the start is, what technologies do you all use? Any WPF developers? Yay! C#? Web-based?
Mostly, but I dabble in everything.
You're going to love the fact that I said it was web-based. Would you like to see the web-based version? Yeah.
Where do you buy the cameras? Where are the cameras on sale?
Yeah, direct from Intel.
Sorry.
Yeah.
Got dev kits.
Yeah. The reason you buy them from them is because they're actually not encouraging you to buy from them. Actually, what I want to do is, because it's still recognising my hand movement, it's not letting me shut down. It's going, you're moving your hand! So, so the dev kit's available, but they want you to be buying the Ultrabooks. They want you to be buying the hardware that's got this in. If I just go into here to the RealSense SDK, and if I go into this framework, they have a very confusing naming convention in here. You'd think that the samples would be in sample, wouldn't you? Yeah. So there you see the different. So they have language-specific samples. So the JavaScript, right? You wanted to know about effectively wireframes, and you wanted to see what nodes it tracks. Right. We'll put some gestures and alerts on. Let's just stream this in.
Nice. Very cool.
Yeah, it is, isn't it? Oh, by the way, I want 2 hands. Now, the really weird thing here is because I've put that hand up first. Hello. That's my right hand. You'd expect that one to be the one over this side on the screen because you think it would be reflecting, and it's not. It's swapped over. It's actually showing me the image from this way. So I take it out, bring it up. There's the left hand. So now you're on about gestures. If I bring my hand back into view, there's a full pinch. There's the V sign. No, I'm not doing that gesture. Nearly. The one I will show you when the camera's off. The one I felt sorry when I looked out and I could just see this lad staring at me with horror on his face. I think, what have I done wrong? And afterwards somebody said, "Do you know that's really offensive?" So yeah, so you've got all these sort of little gestures and things. So there's you can do full pinches and you get your hand moving like that. So that's one of the SDK samples there. But how about face tracking? Yeah, let's get some pose data in there and some expressions, because you're about to see me gurning. So that's telling you what the size is, the 640 by 360. Right. Oh, lost me. Please don't mock me. This is all for the demo. You have to try this at home. When you get the camera, make sure you're in a room on your own. By the way, it uses the shape of your mouth and eye points and that for the emotion detection. Then, the one that has the most fun with my particular accent. I spent a lot of time working with Intel on things like... Now, the voice recognition internally uses Dragon. And it's shipping and built in. So what I'm going to do is I am going to use dictation mode. Hopefully it'll pick my voice up. The room's a bit noisy and a bit echoey, and sometimes in conditions like this it doesn't work too well. However, if I talk like this, let's see what happens. That's pretty good. That's with me doing my very posh voice. Yeah. Now when I talk like I talk normally, if I was to talk like this back home, you're right there, buddy lad, how's it going? And that's a problem with voice recognition at the moment. It recognises that at least. So yeah, that's you know. So these are JavaScript samples. Yeah, they're in the SDK. They're available. Again, voice recognition. You don't need the RealSense camera, so you can try that one at home. And as you all have much more clear accents than I have, it's going to work a lot better for you. Okay, now I did say that I had games. So that's the end of my official talk. But anybody wants to move it like King Julian? Yeah, it should be. I know what it is. Did I believe? I should have closed it down. It's tried to get control. So. You think I'm doing this for fun? Hey, this is serious business. And this is what I say, man, you get the hands. So you can see there, the hands are recognised. So move the hand up. And you're all welcome to have a go. That was me in the hotel room being caught doing... Please, anyone else have a go?
Show us how it's done first.
Okay, I'm happy to make an idiot of myself. Those who know me, that's my default state. Okay.
Yeah, you got it!
Anyone like to have a go? Go on. I'll switch it off the big screen if you don't want to. Every gesture they made was translating. That was my excuse to them. Okay, basically, perceptual computing. The basics of it is it allows computers to perceive depth. That hence perceptual. It's not just depth that they're perceiving, it's voice, it's colour, it's trying to mimic the way we see things. So the techniques it use are analogous. Things like they've got an infrared camera and they use that to bounce beams and to capture depth data. Kinect users? Yeah. You're used to the idea from Kinect
Yeah,
of
I'm
that.
playing with the SDK and built some basic interfaces, but
Yeah. What I'm going to talk about as well as covering the perceptual computing, I'm going to talk about the differences between the different types of perceptual computing. So things like the Kinect, the Leap Motion, and the Intel offering. Right, this is your first bit of tactile. This is where I get up and say, right, this is a RealSense camera. That's it. Please, pass around. That's a 2D and a 3D depth camera. But then again, so's that. This tablet you can buy, commercially available. On the back there's your standard camera, and here is a RealSense camera. So available now. Okay.
How much is one of these?
That is it's $99.
Okay.
Gets better.
it's a mini Kinect.
It's a mini Kinect, and it gets better in that actually you can buy Ultrabooks with them in now. Currently there are 15 Ultrabooks on the market worldwide that have RealSense cameras in. My personal favourite is the Republic of Gamers one. Oh, it's a beast. Trouble is, it's about 17 inches, but my God, it's amazing. Playing Elite on that with using gesture, it's fantastic.
Just got a new laptop last week.
Oh, sorry.
That's work for another.
Yeah, it broke accidentally. Yeah, the RealSense cameras are now being built into devices. So what you see there, in terms of that camera, that you're actually getting inside hardware now, and it's ultrabook, so it's your housekeeping when she comes in, and I walked back into camera shot on the character and it went, whoa! Because it picks you up, recognises you, and does it. It's got facial recognition built in. So it can sit and recognise you. So in the book case, it could recognise that you're up to page 30. You could give it to your sibling who's maybe at page 15 and it'll take them to the appropriate book, appropriate page. With emotion detection, it can say things like, you look sad. How about I make this a happy ending? Or if you're my daughter, who doesn't seem to like stories with happy endings, go, you're too upbeat. How about if the main character dies? Probably from some lingering disease. Oh. Okay, we're talking about natural user interfaces. Again, this is one of those strange terms that comes up. It's a very amorphous term. It means different things to different people. But basically, natural user interfaces are the next step. They're an evolution away from GUIs. They're a way of saying, actually, you're going to interact with the computer in other ways. It's not just going to be a button on the screen that you press. Microsoft took a big step towards that with the sometimes lambasted Metro interface. You know, when they went with Metro or New, or as it's now called, Windows interface. They made that step on because they realised that form factors are changing, usage scenarios are changing. So people don't want fiddly little tree views. They want big buttons and they want things outside across because they're using things with their thumbs. Well, we evolved this because now we're using things with our hands, we're swiping. By the way, that's a great thing to do on a train, control the computer with your hand recognition. Because I guarantee you can get a carriage to yourself if you're sitting there going. The thing I'm worrying about now is that camera's just caught me doing that, and that's for posterity. Has caught me looking like an idiot. And normally I save that for people I know. Okay, so the different types of cameras. What types of cameras do we have? Well, what we have here, that device there, the first one you saw, that's a front-facing camera. Now, that camera is called the R200. Sorry, the F200. The R200. I'll give you a clue. There's an Intel naming convention. If it says F, it's front-facing. The rear-facing is the R100. That's the one that was in the tablet you saw. Just to interact with computers in a different way. So it's waving your hands around. It's gurning. It's pulling faces. It's emotion detection. It's an up-close device. That's what I say, it's inside the Android tablets, it's inside laptops, it's inside ultrabooks. It's designed for being up close. It's not designed like the Kinect for distance work. The Kinect is a great device, don't get me wrong, it is a fantastic device. If you want to play a game and you want jumping around in a room, the Kinect is fantastic. I love it. If you're wanting to interact with your computer and actually operate it, the RealSense is a better choice. And because it's available on other platforms, it spreads out, it becomes much more of a choice for other sort of usages. So you can see it coming up in things like hospitals, you know, the big kiosks where you go and say, right, imagine going up to the kiosk and going, show me where the dentist is, and it traces a path through from you because it's recognised what you say. That's useful, being able to talk to it. Yeah, voice recognition isn't new, but it's now in the devices. And that's useful because you might be on crutches. So perceptual computing is about giving you the tools, all the tools you need for building compelling applications that can interact with the user in completely different and radical ways. Now, the app we're going to build isn't a radical user application like that. We're not going to do a book, for instance. One of the great demos I've seen is father reading to his child, sitting there. It's your very happy families, and the dad sitting there reading the book, and I'm like, oh yes. And the child's sitting there, and they've done 3D segmentation, so they've extracted the background from the child and put the child in the book. So the child's actually interacting with pictures in there. That is a fantastic, fantastic thing. Most of what you'll see with RealSense at the moment are games, because the games companies have leapt on this rapidly. They're helping to push forward the innovation. There is one of the games I'll let you play afterwards is Lego. Oh yeah. Oh yeah. I was testing the camera this morning to make sure it still worked. In the hotel room. Knock at the door. That thick. So it goes in the case. So where you would have the web camera before, now you've got one of those. That's Android, by the way. It's not just Windows. There's difference number one with the Kinect. But why? Sorry?
What is this Dell device?
That's an 87000. It's a Venue 87000. Yeah, it's about £300. Afterwards, please feel free to come up. I'll switch it on. You can have a play, try with the camera. Because of the camera on the back, you can do all sorts of fantastic things like refocusing. So you take an image, it will take all of you in depth, and then you can refocus. So you can pick, you're sitting at the front, and then you can do things like adjust the amount of blur, and you disappear at the back. You can do things like, okay, so right, I want to do colorization, and pick a person and say, right, okay, everything else is going to be black and white, but you're going to be colour. It gives some fantastic effects. Yeah, it's toys, and I love toys.
Can I take wireframe images? So you've got a 3D object in front of you, take a photo, and it builds a wireframe of the image in front of you.
You can actually do that with, not with that device, not with the Android version at the moment. You can do it though with the one in the Ultrabook.
Right, what I've been doing with Kinect, basically 3D scanning.
Yeah, 3D scanning is available here.
3D printing yet, but
Yeah. Well, I say it's available. It's one of those things that Intel keep promising that the SDK will have, and they've just released a new version of the SDK. Because we're going to do a live coding session here, and because I had a demo already, I haven't downloaded the new version of the SDK, because one thing they do like doing is breaking the old version. Going, oh, we found a newer, faster way of doing this, we'll deprecate that method and give you this method instead. Which is one of the reasons I'm writing a wrapper application for WPF developers to sit on top and abstract that away, because we can take care of that underneath. So you develop against the API and then let that take care of what goes on underneath. So there's some hideous code underneath going in there for things like, if the version of the SDK is 3.16, go down to this particular branch. If it's 4, go down here. But the reason for doing that is it means that you don't have to. And then you can roll out your code to different users using the same code base effectively without having to worry about what's going on underneath. And that's the thing. Why perceptual computing? It allows. Good afternoon, everybody. I'm Peter OHanlon. I'm an Intel software innovator, and I'm talking to you today about Intel RealSense devices. Over the course of this talk, I'm going to cover these topics here. I'm going to show you a brief overview of what RealSense devices are. We're going to do a bit of coding with them. You're going to see how you can interact with them. I'm also going to talk about what platforms are available on, and talk about how you can get involved in RealSense right now. First of all, quick show of hands. Who's heard of RealSense? Oh, amazing. Did you all see, well, the ones who've seen it, did you see the GDC demos earlier on this year? Oh, you missed. Unfortunately, I'm not allowed to show them because it's copyright Intel. But go and search on them online on YouTube, and that's absolutely incredible. There's 4 guys standing on a stage playing drone pong. Seriously, they're standing in corners and they're just passing the drone backwards and forwards between each other using perceptual computing, just using gestures and making it move backwards and forwards. I've got no drone with me today, so we're going to have to do something else. I do have games you can try. Do have RealSense games. I was going to do a bit where I said, get somebody up and get them to try and that. But that's purely voluntary afterwards. If you want to have a go, please feel free. Okay. So, RealSense devices. RealSense devices are perceptual computing devices, basically. That's what Intel used to call RealSense. It used to be called perceptual computing. I first got involved with RealSense back in the perceptual computing day when we had perceptual computing cameras back in 2013. I was part of the group, the Intel Ultimate Coder Challenge, going perceptual. A group of people who got together to battle off and try this new technology that none of us had seen before, but which was a gesture camera. It was an astonishing device. It was really big, really clunky and really heavy. And if you had an ultrabook like this, which is what it was available on at that time, you'd plug it in and it would pull your screen backwards, which was great on a train because you'd be sitting coding away and the person opposite you would realise all of a sudden that they were staring at themselves on a screen